This video is just going to cover using the formula, the point gradient formula for finding the equation for a line. There are other methods, this is just one. So to do any question that involves the point gradient formula, you obviously need a point and a gradient. The formula simply is an extension of y equals mx plus b, really, where we know a single point and we know a gradient. So if I know a point and I know a gradient, it is purely a matter of substitution and nothing more than that. So y minus, in this case, that's our y value there of 3, m is 4, that's an x value there, so x minus 2. And then I'm multiplying in 4x minus 8, move the 3 over the other side and I can get it in gradient intercept form. So that would be 4x, add 3 to both sides, and I've got minus 5. Let's talk about this though, because sometimes they don't give you all of that information in one go. They'll often give you a point, but they'll give you some other piece of information. They'll say something like parallel to another line. They might say parallel to y is equal to 4x plus 7. Well, what do we know about lines that are parallel? They have equal gradients. So I'd just be taking that 4, and that might have been how I worked out the m equals 4 just there. If they're being less kind, they might take something like 3y minus 12x plus 28 is equal to 0, for instance. And then they're saying that we are parallel to that line. You're still going to have to get it down to y is equal to. So in this case, 12x minus 28. We're really only interested in a gradient, so we can divide by 3 here, divide by 3 here. And maybe that's how we found out that the gradient was 4. Or they could have said to us something like, it's perpendicular to another line. Now, if we remember our rules about perpendicular gradients, two perpendicular gradients multiplied together equal minus 1. In this case, my two perpendicular gradients, I must have concluded somewhere along the line that I had something like minus 1 on 4x plus something, and they might have said it goes through this point and it's perpendicular to this line. And so I look at that gradient and say, the negative inverse of that is 4, so that's how I got my 4 to start this question. All of the time when we have a gradient and a point, we can just go straight to the formula and substitute in. But sometimes there might be a little bit of work along the way to define our gradient.